In this example, we will compute the Laplace transform of u sub 2 of t times sine of 3t minus 6. We found that the Laplace transform of a shifted function is given by the formula Laplace of u sub c of t times f of t minus c is e to the negative sc times the Laplace transform of the unshifted function f of t. To proceed from here, we need to write sine of 3t minus 6 as a shifted function f of t minus c for some function f and some value c. We can see from the step function that we want it to be shifted by c equals 2. And now we need to write the rest of the function in terms of t minus 2. That is, we need to find a function f of t so that f of t minus 2 is sine of 3t minus 6. We can do this here by writing 3t minus 6 as 3 times t minus 2. So we have sine of 3t minus 6 can be rewritten as sine of 3 times t minus 2. So, using f of t equals sine of 3t, our original function sine of 3t minus 6 equal to sine of 3 times t minus 2 is f of t shifted by c equals 2. Bringing this back to our original Laplace transform, we have that the Laplace transform of u sub 2 of t times sine of 3t minus 6 can be rewritten as the Laplace transform of u sub 2 of t times sine of 3 times t minus 2. And now that we've written our function in this shifted form, we can compute the Laplace transform as e to the negative 2s, since c equals 2, times the Laplace transform of the unshifted function sine of 3t. And using that the Laplace transform of sine 3t is 3 over s squared plus 3 squared, we get that the Laplace transform of u sub 2 of t times sine of 3t minus 6 is e to the negative 2s times 3 over s squared plus 3 squared. In some examples, we will be given f of t in its shifted form. In other examples, like this one, we will need to figure out what the shifted form is. Like here, we had to rewrite sine of 3t minus 6 as sine of 3 times t minus 2, since we could see from the step function that c was equal to 2.